Okay, so next unit is exponential, logarithmic, and logistic. I'm going to work first of all with exponential and logarithmic just to make sure we finish them. Log was the last thing you did with me in Algebra 2. So, you know, I want to make sure we have a firm grasp of logarithmic, and if we don't do logistic, we don't do logistic. So just quickly, what I want to remind you, exponential is the easier of the two. You've done exponential in Algebra 1 and Algebra 2. When I have this screen, the natural base E, we talked about E 2.718, keeps going, natural number. And there's not much we're going to be looking at with that. But we do with ln. So when I say we're going to look at exponential functions, we just got done with polynomials. Polynomial, I have x squared. My base is x or a variable. My exponent is a number. Now I'm switching it up. My base is a number. My exponent is a variable. So, we switch that up and we now have an exponential function. So, exponential function with base b, a times b to the x. This is my base. Now really what you're going to see, a is your vertical stretch or shrink, or it could be flipping it over the x-axis. So, the thing being raised to the power is the base. A cannot be 0 because then you'd have nothing. B cannot be 1 because then it wouldn't be changing. So it has to be positive. The fact that if you have a negative, as I just said, that's a reflection. When we do word problems tomorrow, A is really my initial value. B is my base. My domain, all real numbers, because I can take any number to any power. When I really am just doing the basics with this. So exponential growth and decay. When do you have growth? You have growth when b is larger than 1. When do you have decay? When b is between 0 and 1. Can't be negative. It's positive. Can't be equal to 1. I don't have any equal signs there. Okay? So next thing we really think of, we look at the graphs. Well, I hope we remember exponential growth. This would be growth. A is greater than 1. So if I'm looking at this, 2 to the x would be this. 3 to the x, I shouldn't use red, is going to go up quicker. 5 to the x is going to go up quicker still. They're all still going through this point, 0, 1, because anything to the 0 power is 1. Now, when do you get decay? Now, we could say that if you flip growth over the y-axis, which is what that would do, you have decay. But if you really think, what is 2 to the negative x? 2 to the negative x is 1 over 2 to the x. Well, that could be written like that. Same thing with 3 to the negative x, 1 over 3 to the x. 1 to any power is still 1, so we can rewrite it. So when we look at that, my a is between 0 and 1, and so I'm getting decay. What do those graphs look like? Same thing. I start out, I get flat. Okay, so when we think about, though, what point is on all of them? As I said, 0, 1, because anything to the 0 power is 1. I could write A or B, doesn't really matter. So just in general, we did this earlier this year. Basic function was really e to the x, but we looked at growth and decay. When we look at 2 to the x, domain, negative infinity to infinity. Range, 0 to sorry, not 0 to 1, 0 to infinity, but they're both parentheses. You cannot take 2 to any power and get it to equal 0 or a negative. It is always a positive number. If I talk about the horizontal asymptote, y equals 0, it is never going to reach 0. Now, when you think of end behavior, and if I say, let's use limit, if I say with growth, as I go to the right, my graph is going up. As I go limit as x approaches negative infinity, I'm getting closer and closer to 0. So the strange thing about exponential functions is to the right, one of them goes to infinity, or negative infinity if it's flipped. To the other direction, it goes to 0, or a number if it's shifted. So then we look at decay, which, as I said, could be a flip over the y-axis, which you could show with 2 to the negative x. Same thing happens. Domain, negative infinity to infinity. Range, 0 to infinity. Horizontal asymptote, y equals 0. But now it's different. My limit as x goes to the right is actually 0. My limit as I look to the left is infinity. So decay starts out high, gets flat. Growth starts out flat, gets high, looking at it left to right. Graphing using shifts. So again, we know those general shifts. Just be careful in thinking this is controlling whether you have growth or decay. Okay, that is not a shift. This is you're shifting b to the x. So A is your vertical stretch or shrink. Okay, if it's negative, reflect over the x. C is actually, it has to be factored out. Horizontal, stretch or shrink, we always know it's the reciprocal, not what we think. If it's negative, over the y, reflect. D, left or right, which if you think left or right does not really change anything. It's just sort of moving the graph. E is up and down. Now, the thing you want to think of really, what is E changing? If that whole graph moves up and down, that graph has a horizontal asymptote. So your new horizontal asymptote is going to be what that shift is. And that's really the point, the line that you should be shifting. So, what would I say with this? If I said, what is it? Vertical stretch, I'm just writing it like that. Vertical stretch factor of 2. 3 just means it's growth. Okay? This means left 1. This means down 5. Now, again, you think of order. This would be 1. This would be 2. This would be 3. Or left 1 would be first, then vertical, then down. So when I graph that, what do I think of graphing? I know that now it's never going to touch negative 5. when you're thinking of really like the left and right, I mean, the point that this used to go through was 0, 1. That's actually moving right 1. I'm sorry, left 1. Um, you could find some points if you had to. You could find the y-intercept. You could find the x. You can't really find the x-intercept yet, but I mean, it's growth. It's going up. It's never going to touch -5. I don't even think you're asked to draw them. You're really just asked to, I ask, describe it. I don't take your calculator away for any of this. So if I said describe the transformation, write 1, it would be exponential growth because of 2. This, if I said describe it from 2 to the x, this would be a reflection over the y-axis. Okay, C would be a vertical stretch of 3. Natural base E, just the only thing I mean, I'm trying to go quick, as I said. Basic function e to the x. There's all this stuff about what e is and where it's derived. E is 2.718, blah, 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 blah. It's growth. So if I said, what's its domain? -infinity to infinity. What's its range? 0 to infinity. What's its horizontal asymptote? Y equals 0. None of it changes. It just has different points. It's not 2. So if I say what's being done, this would be a horizontal shrink of a half. Second one would be a reflection over the y-axis because the x is negative. Third one would be a vertical stretch of 3. Again, we just want you to know that e is a number, and when we talk about logs, e and ln, e does come in. So that is sufficient for you guys to be able to sort of a quick introduction of exponential functions. We'll see you tomorrow.